everyone.
Hello, everyone, and welcome to this session of Digital Futures Young on the topic of sea level rise and climate change. This follows a session that we had 2 weeks ago, co-hosted with a few very interesting guests that were Jesse Keenan, Darren Othmane, Aya Mohanna, and Giovanni Cecconi, looking at this topic in very different parts of the world. And today we follow an open call for presentations that we launched a few weeks ago, where we had a series of responses from all around the world. And I think it's very interesting to see the diversity of the presenters that are gonna share their work with us today. We're gonna have Danielle, Khoury, Gregorio from the University of Sao Paulo, Jodel, MEKEMTA, and Sidoine TAKAM from the University in Togo, EAMAU, then Othmane, Kandri from the AA and CAS, Alberto Fernández and Nicoletta Karastathi from UCL, the Bartlett, and then Maria Flores from Florida International University. So just before starting, a quick mention of the upcoming conference of Digital Futures 2021 Inclusive Futures at the beginning of this summer. And we wanted to highlight to you that there is the call for paper that is still open for, I think, more or less a week. So please have a look at the call for paper also on our Discord and on the webpage of Digital Futures World. The conference is published with a very high ranking and is free and open to everyone. So a very brief introduction before giving the word to our speakers. 2 weeks ago, Jesse Keenan started his intervention saying that the problems with water is always that there is either too much or not enough. And I think that's something that is going to resonate with many of the presentations today. We have seen how the difficulties with the world of water due to climate change around the world are concerning very global issues, but at the same time also affect very local conditions. And if 2 weeks ago we have discussed about very paradigmatic cases like the situation of Venice in Italy with the dynamic dams that have been just activated, or the case of Miami and the coast of Florida and of northern Egypt. Today, we are going to also move around the world from Antarctica to the Amazon, from Lagos, and again back to Florida and other regions of the world. Somehow different expertise and different design cultures relate to this topic in very different way. And I would say that the presentation we're going to see today, more than giving responses to this huge and very complex issue, will suggest very different way of approaching the issue, and of that architecture and design can learn from in order to approach such a gigantic question that an author like Timothy Morton would define a hyper object for the difficulty of conceptualizing it. But at the same time, another thing that I guess was very prominent in the presentation 2 weeks ago was the fact that so many aspects and disciplines are related to this issue. So it is often easy to move from technical aspects to ecosystemic consideration, economic factors, but also socio-political and more. So that is also something that it would be interesting to unfold in the debate later, where we are going to try to correlate the different presentations between each other and promote a discussion among the presenters and together with the questions from the chat and from the team of Digital Futures. So for those following in streaming, please feel free to post your questions in the chats and they will be brought up in the conversation. Thank you very much also to Mariam Morsi for joining us and helping bridge the language gap with the presenters from Togo. Okay, so without further ado, I would leave the space to Danielle, Khoury, Gregorio to start presenting. Danielle, over to you. You're still muted, Danielle.
Sorry, I will share my screen. So good morning. First of all, I would like to thank Digital Futures for the opportunity to present my research and everyone who is watching. My name is Danielle and I'm a Brazilian architect. I graduated at the University of São Paulo, and I also studied 1 semester at the German University Karlsruhe Institute of Technology. And since 2016, I have worked in architecture studios in Europe and Brazil that were renowned for their commitment to environmental issues, which then motivated me to expand my knowledge in how to integrate sustainability, technology, and architecture in order to create solutions that minimize impact of society in the environment. And those experiences inspired my final graduation thesis, a social housing project for the low-income riverside population of the Amazon. The project aims to solve the lack of housing while taking into account socioeconomic, environmental, and cultural particularities of the region. And the thesis emphasized the importance of rescuing the qualities of vernacular riverside architecture present in local stilt and floating houses. Therefore, the building allows the residents to identify with the house while valuing the Amazonian way of life and local knowledge. But before I started to design an architectural project in such a complex area that is the Amazon, it was necessary to understand the local specificities, such as the local culture, landscape, and climate. And the studied area has a predominantly hot and humid climate, where 2 very distinct periods stand out throughout the year. The period of constant and strong rains, known as regional winter, which comprises the months of January to April, and the Amazonian summer, marked by less frequent rains from June to November. And this variation between periods of dry and periods of abundant rains has a great influence on the configuration of the local landscape. The volume of the rivers in the Amazon basin vary throughout the year. For example, the level of the Negro River, which is one of the main Amazonian rivers, has a variation of around 10 meters between the peak of the largest flood and the peak of the ebb. And depending on the time of the year, the width and extent of riverbeds change, islands disappear and reappear, and lakes and ponds expand and contract. The rhythm of the waters not only changes the landscape, but also influences the life of the riverside populations who have adapted their way of living to this annual variation. In this way, the rhythm of the waters imposes the rhythm of life in the Amazon. Inhabiting the floodplain area requires adapting to the hydrological cycle of the rivers, and the adaptation of the population to the local environment is reflected in their traditional architecture. There are basically 2 different types of housing, the stilt and the floating houses, and both present solutions that bring inventiveness and adequacy between technique and the environment. The stilt houses are built on wooden pillars. They have a simple configuration, usually with only 1 room that works as a bedroom, a living room, and a kitchen. And this type of layout allows a good ventilation of the internal space of the house, being an example of an adaptation to the local climate. The house is built using local materials found in abundance, such as wood, jungle vines, and leaves. And then floating houses resemble the stilt houses in the choice of construction materials and layout, but differ in the fact that it is not attached to the ground. It floats on water, being able to change places. And in addition, it has the advantage of being less vulnerable to river floods and ebbs. The traditional house is built on logs of asaku, which is a light wood with low density that floats on water. It is a typical tree of the floodplain forest, so it's very resistant to the water and it can be used for more than 40 years. And this traditional architecture was the main inspiration for my project. The project proposes a housing complex in the city of Manaus for the low-income riverside population living in precarious and risky situations. Manaus is the biggest city in the state of Amazonas. It is located in the center of the Amazon Basin at the strategic confluence of Negro and Solimões rivers. The city faces today a major housing crisis. With the lack of public policies and efficient urban planning, part of the population began to live on the banks of the rivers in an inhuman and precarious way. In these occupations, the lack of sewage and garbage collection is frequent, aggravating the environmental degradation of those areas and facilitating the spread of diseases. And some housing projects were built in response to these problems. However, in general, the architecture and way of life traditionally developed by the riverside populations were ignored, generating dissatisfaction and difficulty of adaptation by the relocated residents. The Brazilian social housing projects had mainly a productive and quantitative basis. And the production of constructively standardized buildings was intensified. Widespread formulas were adopted in many Brazilian cities, which disregarded urban, social, and cultural local specificities. So this work is a criticism of the current production of generic models that ignore the particularities of the Amazon culture. It emphasized the importance of rescuing the qualities of vernacular riverside architecture, incorporating features in its design familiar to the residents of stilt and floating houses. Therefore, it allows the residents to identify with the house while valuing the Amazonian way of life and local knowledge. The housing complex is located on the banks of the Quarenta River, a region currently occupied by irregular stilt houses. The intention of the project is to provide a housing alternative to the residents who live in dwellings in risk of flooding or collapsed. And the design of the housing complex was inspired by the traditional Amazon architecture in such a manner that the building is in harmony with the people and the natural landscape. The level of the Quarenta River has an annual variation according to the seasons of floods and ebbs, and this variation was taken into account when developing the project. The results of the analysis was the establishment of 3 distinct levels, one variable according to the water level of the river, one at the level of the street, and a third one elevated. At the variable level, a space is created for a diverse use like resting and fishing, and it allows for a continuous dialogue with the local landscape. And at the street level, there are spaces for social, cultural activities, and the dwellings are located on the upper floor. The building's implementation was designed to ensure a harmonious integration with the surroundings. A connection with the other side of the river is proposed, facilitating the access of the region's residents into the cultural spaces situated in the housing complex. And at the same time, the project integrated the leisure areas located on the opposite bank. The building is not only restricted to the housing use, but also serves a purpose in providing social facilities, markets, and spaces for leisure and rest, features that are essential for human development. An emphasis was placed on programs associated with job creation in an educational and cooperative manner, using the local know-how to generate income, like, for example, a fish and fruit market, a boat building school, a bakery school, and a recycling center. The project also holds a canoeing club, which promotes physical activities and reestablishes the relationship between man and water. In addition, the housing complex has ample external spaces, encouraging contact with nature and promoting community life. So the project not only offers quality housing, but also a space that fosters culture and leisure activities. And as a result, a sense of community is created and empowered. And the access to those activities is intended for not only the residents of the building, but also the surrounding communities. In that way, the projects generate a micro-local economy and a cultural center for the region. So these are the floor plans. On the left, we see the floating level where there are some nets, but people can lie down. And on the right is the ground floor. Close to the river, we have the cultural and social spaces like the canoeing club and the community center. In the middle, there are the apartments for physically impaired people and elderly. And parallel to the street are the markets, the bakery, and the boat building school. And here you see the upper floor where there are the other apartments. And on the right, we see the roof plan with the solar panels. Here we see sections and facades. And this is a section in perspective showing the 3 levels. There are 2 types of apartments, one with 36 square meters and the other one with 54 square meters. And the units have full internal partitions inspired by the typical floor plan of the riverside dwellings. And the idea is that the residents can adapt the units according to their needs. And these are the units from the ground floor that are adapted to the wheelchair. The material used for the main structure is Itaúba, which is a local wood with high durability and resistance to humidity. It is used in the pillars, beam, and trusses, and the advantage of using reforested wood is that it absorbs carbon dioxide during growth and generates less residues during the construction phase. And the pillars are made of wood and concrete, and this second material is used at the base of the pillars where there is a direct contact with water, and this ensures a greater durability of the structure, preventing damage of the wood. And the roof develops a fundamental role in guaranteeing thermal comfort to the building because it is through it that the greatest thermal load is transmitted. So it was designed in order to achieve a good adaptation to the local climate. The roof has 2 layers. The outer layer shadows the inner layer and minimizes the heat absorption of it, avoiding the heating of the interior of the building. And the heat accumulated between the 2 covers is removed by ventilation through an upper opening. The overhangs prevent direct sunlight from reaching the interior of the building during the hottest time of the day, while also protecting it from intense rains. And the high humidity and elevated temperature of the region can cause a constant feeling of thermal discomfort. Therefore, it is necessary to promote dissipation of heat through ventilation, and for this purpose, the building is open in order to capture winds. This is done through the external panels, which have an area for permanent ventilation. And the building is also elevated from the ground, providing better exposure to the winds, while also allowing an air movement below it. The rainwater is harvested and utilized in toilets, and also the sewage water is treated so it does not further pollute the rivers. And here we have some 3D image. This is a 3D image of the apartment. Another image from the apartment showing the large windows for ventilation, a view from the ground floor during the flood season, and a floating level and external spaces. And this is the circulation and external area. Thank you so much.
Thanks a lot, Danielle. So we are now gonna move on to Othmane.
Yeah, can you hear me?
Yes.
Perfect. I'll try
to. So over to you.
Share my screen. Just a second.
Yeah, all good.
All good?
Please.
Perfect. Yes. Okay. So hi everyone. My name is Othmane Kandri. I'm 24 years old. I'm from Italy. And after graduating in architecture from University in Venice, I essentially moved to London to kind of explore new sort of architectural repertoires. And I joined for my MArch, the CAS School of Architecture and the DAA School with an exchange program for almost a year and a half. And my personal interest are based on computational design applied to urbanism, looking at the scale of a city or a territory where kind of landscape and urbanism merge in a sort of unique dialogue. So currently, after finishing my master, I joined ZHA to kind of continue this exploration in experimentation. And today I would like to present to you the work that we produce at the Polar Lab, which is an academic research platform of Antarctica 200, a cross-disciplinary project that kind of has an interest on conceive and shed light in a very mysterious continent, not very well known. In fact, for the 2020 anniversary, the project aims to kind of freezer and map the evolution of the Antarctic architecture and Antarctic climate, producing a body of research that would be debated at the next Venice Architecture Biennale. Okay, so we can start with the geographical location of Antarctica, which is the Earth's southernmost continent, and it contains the geographical South Pole, and it is situated in the Antarctic region, almost central south of the Antarctic Circle. Antarctica, on average, is the kind of coldest, driest, and windiest continent, and has the highest average elevation of all the continents. And most of Antarctica is a polar desert, where 80% in a way of the world freshwater reserves are stored there, enough to kind of raise the global sea level by about 60 meters if all of it were to melt. So try to think about the impact of this in our cities. And the temperature usually varies from minus 90 degrees to 20 degrees Celsius. This is an interesting image of a small part of the continent from Google Maps that in a way is our most important kind of surveying system in the planet that underline the fact that there is a lack of information and data regarding the climate, the political, and the urban agenda of Antarctica. The fast kind of melting of the Antarctic ice cap induced by the global warming will gradually kind of alter also the international geopolitics, because in fact the territory of the Arctic is a very important kind of strategic outpost to ensure access to research and science that is done on site, and energy and commercial resources, as well as very important military strategic area. However, the science is very clear. Climate change is already negatively impacting Antarctica, and the problem of kind of human-caused climate change is now very well known, which is the concentration of greenhouse gases in the atmosphere, very well above the sort of pre-industrial levels due to our use of fossil fuels, but also to deforestation, agricultural practices, and ultimately urbanism. So the first map kind of showed both the ice sheet and the sea ice as a sort of potential area subject to change during the warm season. And in fact, the ice shelves are kind of floating extension of a grounded ice sheet. One of the largest ice shelves, for example, just to give you an idea about the scale, is slightly kind of smaller than Spain or France. So each summer, a significant amount of meltwater, for example, is produced. The climate in Antarctica, has warmed by 3 degrees, meaning that since the 50s, there is a loss of almost 25,000 square kilometers of ice shelf. And here we can see in a way how during winter the continent creates new ice formed from the ocean water and the general snowfall. In fact, when a certain threshold warming is reached, these regions might start kind of melting significantly. And the temperature, when the temperature comes down again, the ice will not immediately regrow. So we can kind of read this sort of continuous tension and compression of the entire system that is based on one hand on natural and behaviors, on the other hand on human behaviors that obviously exist in Antarctica. And part of our agenda was to obviously critically unveil and visualize this unique nature of the human presence in this vast polar territory, because since the 50s, numerous research stations were built at this time, introducing also kind of interesting typologies that look at technological solutions that deal with the climate and wind landscape. In fact, as you see from this map, a number of governments have set up a permanent research station in Antarctica, and these are based that are widely distributed. Constructs are either on rock or on ice. And in this case, there's a sort of trend that drives towards a sort of climate urbanism on one side for the location of the base in the continent, and on the other hand, on the political treaty. In fact, most of them are kind of located in a geographical area close to Argentina because of the less travel distance with the ship and with the aircraft, and because of the warmer Antarctic surface temperature than in the central area. But there are also other human activities in Antarctica that are happening and that are regulated by the Antarctic Treaty. For example, tourism. And although tourism has grown from a few kind of hundreds in the beginning of the 50s to a total of approximately 5,000 people every year, and obviously this is expected to increase in line with the worldwide trends. And at the same time, this will kind of increase the demand of infrastructure in the territory, pushing even more the sort of urbanization of the continent. So in the past kind of 20 years, several research stations have been kind of built, implementing building techniques that lead to development of sort of mobile, responsive, but also zero emission structures. And we try to kind of collect this data to kind of map the architecture of the bases from several images, papers, and documents, and how in a way the base is rated to a specific kind of climate and the site. And to give you a little bit of context of what does it mean building Antarctica, these are very interesting examples. And most of the time, the client's brief is related to a typology easy to ship and build on site. The building has to allow for sort of replacement of individual multiple facilities. They try also to minimize environmental impact with energy efficiency, reducing the use of water and improving the waste management. And to provide also flexibility to support the sort of scientific program that is done on site. But looking at the same time at the wider context of the single base, there are interesting examples of territories like Punta Arenas and Hobart that becomes in a way the port of entries in Antarctica. In fact, this strategic location of these places promote the development and the flourishing of these places into sort of logistic hubs. That's why the interest in urbanism, and not only in the kind of single architecture of the base, becomes, in my point of view, even more kind of relevant to address a sort of sustainable order that takes in consideration the transportation of goods, the waste management, the construction of new kind of infrastructure to minimize at the same time the gas emission and the land consumption. Because this is the result. And the idea of a sort of meaningful urban design is completely vague in a way, because obviously there's an ambiguous sort of mix of several issues to resolve within the site, such as the architecture of the base, the architecture of the landscape, and the overall kind of planning of the supporting infrastructure around the base. And questions obviously arising, such as what is the relationship between the landscape and these new urban settlements? And what is the strategy in a way to reduce the vulnerability of the climate and the overall natural ecosystem? This is a typological plan of a base. In fact, as you see, most of the time, the result is a sort of complex urban asset where the location of the central base deal with extreme climate and topography, as well as a huge amount of facilities that are necessary for the operation of the base, such as the fuel tanks or the workshops, power facilities, parking areas, and most of the time kind of run away for the aircraft. An approach that obviously transforms quantity into sort of generic efficiency through compact massing and repetition. And it is also worthwhile remembering that building in the Antarctica have probably the largest kind of construction carbon footprint of any other buildings in the world. And we try to map this data. Everything has to be, kind of flown or shipped there, and anything that can fit into an aircraft has to be assembled elsewhere and then shipped several times. So a process of sort of accumulation that ultimately generate what we call today a city. And mapping and visualizing this data allow us to kind of run also some simulation through parametric design that visualize current and future scenarios of a specific base. And as an additional study, we went obviously through the impact that each station in a way kind of had to in its context, according to obviously its master plan and the configuration, and numbers of elements, for example, such as equipments, logistic facilities, the number of buildings for each base, and obviously the overall kind of area that occupied the Antarctic soil. And this can give us an overall idea about the production of energy that every base needs to operate throughout the year and its carbon footprint. That's why I think it is important to look at the continent as a sort of unique urban asset towards a sort of net zero carbon emission, establishing a representative network of marine protected areas or protecting areas which are less likely to change, implementing at the same time a sort of biosecurity measures, putting into place a new kind of management system, which is able to kind of incorporate climate resources and to respond to new type of landscape urbanism. And this is my last slide. In fact, I would like to show you this image because this is the driest, the coldest, and the windiest polar desert of Antarctica, and is seen as a sort of barometer of the global ecosystem. The key in a way to understand how quickly climate change will impact the world through the rising of sea levels. And the impact of the human urbanism in this delicate environment is critical, and at the moment, I would say not sustainable, and calls obviously for a definition of sort of ever-evolving norms and regulation, because in fact, the climate impacts Antarctica won't be a sort of localized phenomena, but it will ultimately affect the entire planet. I would like to thank also the students and the tutors that participate during this jury. And yeah, feel free to send me a message or an email if you have any question. And thank you for your attention.
Thank you, Othmane. Thanks for this interesting presentation and for stating so well the importance of this resource of fresh water, the largest resource of fresh water, which is something that also connects to the next presentation by Alberto Fernández and Nicoletta Karastathi. So over to you.
Thank you. We are going to share our screen now. So can you see? Yes. Perfect. Yep. Yes.
Yes.
Perfect. Okay. Well, hello everyone. Thank you for to be here watching these presentations. And well, I'm Alberto Fernández. I'm in Nikoletta Karastathi. We are MRs and PhD candidates from the Bardo School of Architecture. And now we are working in this project named Coastal Fog Tower throughout the design and fabrication process of a vertical fog capture device.
So we would like to start with some facts regarding water stress. So currently there are over 2 billion people that are experiencing water stress, and it is estimated that by 2050 that might rise to 5 billion people. And also currently 1 in 9 of the world's population do not have access to clean water. And as you can see on the next slide on the map, the global distribution of water stress, on the top you can see how it was at 2010, and at the bottom how it is estimated to be at 2050. And it is also important to mention that it is actually a seasonal effect that happens throughout, and you can see that on the right hand side of the figure. And that means that about 4 billion of people can be without water for about a month in 1 year. So one of the ways that we can help provide water in some of these areas is through a fog harvesting system. How does it work? So typically it's installed in coastal areas or mountainous areas with high altitude. And how it works is that you have the cloud that has the water particles. It passes through the tower or the mesh. The mesh captures those water particles, and with gravity, they travel down the structure and they get gathered on a tank. And now Alberto will take you through the concept of the design.
Well, yes. So this is the first stage, the conceptual design that we started years ago, in which we define 4 parts of this conceptual tower. The first one is the most important, what is the net that is capturing the water. But the second one is the reinforcement system. It's a little framework that can reinforce the full system as well, trying to improve the quality of the water capture during the process. Then the third and the fourth parts are more structural, but all together can create this idea of a vertical device that can capture and can increase at the same time the contact between the net and the cloud, improving the quality of the amount of water that we can get from the air. So then we have the second stage, the structural prototype, that with the main focus of trying to create a highly compact structure that can be easily assembled on site by 3 workers, and then all these parts are no longer than 1.5 meters. So then the full system looks like this one. is that this prototype was built in some hills in the north of Chile without any other things around it, around them. Then the third stage is the second structural prototype, but with several improvements, including the idea of working with a next shape foldable structure, a 3D printer spiral catching network as well, a collaborative structure, and altogether can create this idea of an interior twist that can increase the amount of surface that can capture water in the same amount of time. Then we were working with the 36 3D printed joints that can create this easy structure in terms of, okay, we have again 3 workers working just in one day, and the final result was this one. Near to 10 meters height tower that can catch water in a vertical way. So we have this focus here about how to improve the quality of isolated communities or isolated families in crossing these coastlines in all these South American area. So well, after that, we realized that one of the most important things is trying to reinforce the capture structure inside these towers. So we started to think in the idea of 3D print a secondary system that can collaborate in an active way with the net that actively is catching water. So when we developed this visual algorithm that can create and can iterate this with this idea of a 3D printed blocks. And now we are working in stage 4, we're working with the organization Lima 2035 and in collaboration with the Rockefeller Foundation and with local communities.
So a very brief information. In general, Latin America is known to be a water abundant region. However, if you actually start looking at the local areas, there is a high water pressure identified, and that is because of that happens in the most populated areas. And that happens also in our case in Peru. And these areas can experience water stress that can be above 80%, that it ranges from 3 to 12 months. And now going to our current thoughts for the final prototype that would be in Lima. So we're thinking of these prototypes as a 2-system structure. The one would be initially the more kind of rigid or easy to assemble structure, and then we started to think in the idea of a component, because one of the main issues that the fog harvesting towers currently face is, one is maintenance, and then is the net itself gets torn apart quite easily. So if the component, if then it's a component that fails, potentially you would be able to replace the component instead of the whole net, and you would have better control over the structure. And the other thing that we're thinking is that you have the component, you have the textile structure, then you also have an extra reinforcement, let's say, which could be 3D printed. And within that 3D printed mesh, we also started to think how we can actually maximize capturing water, maybe even by having small extrusions or things that would really help us capture the maximum amount of water. So in the next slide, you can see there are 2 different types of prototypes. This one is a large scale prototype, and it has those 3 towers that work as a group together. And these towers actually serve an irrigation area of 5,000 trees. And it is important to note that to do that work, we really need to simulate and understand the wind pressure and how that affects our structure, and how through design and putting actually those 3 towers together, we can start maximizing the way that, as you can see here, by placing those 3 and make them work as a system, we maximize the way that we capture water through the various surfaces. So one is not as effective as 3. And in the next slides, you can see a few of images of how we envision that potentially to be part of the green regeneration and be part of a public park.
And in parallel, we have this other scenario, which is the small scale, working with the local communities. In this one in particular is the Swan community in one of the hills in Lima. We are working with the same principle of 3 towers working together with a total amount of 27 in this hill. We're producing now 120,000 liters per day in a maximum amount of capacity. So it's similar to the bigger one, but with some variations, including the triangulation system. It's more efficient in a certain way, and at the same time, we are thinking about this idea of folding or unfolding a structure. And well, we test the system again, we modeling or the full topography there, and trying to place every group of 3 in the most efficient way possible. And we are understanding at the same time that the same phenomena of 3 that are accelerating in a certain way, they are accelerating the wind in between, and in the same time they are increasing the amount of water particles clutching between them. Is working in the same way, and the increment of efficiency is in a 50%, which is huge. And this is one of the last images that we have here. That's an objective of this virtual scenario in which the community can grow later around this new set of towers. And now we are exploring this idea of how to reinforce this triangulation using an hexagonal pattern as a component that can create a stronger relation between the structure, the net, and the 3D printer process. So this is our team till now. All the people is involved in this design, and thank you very much. And these are our links for Instagram if you want to contact us later. Thank you.
Thank you very much for the presentation and for this sharing about this very, very inspiring project. So now perhaps we could have Maria Flores presenting, if you are okay, Maria, just because we are still checking one technical detail for the last presentation. So Maria Flores from Florida International University, please, over to you.
Hi, how are you guys? Thank you so much for this opportunity. You all can hear me well, right?
Yes, perfectly.
Okay, perfect. So let me share my screen. Right. So hello, everyone. My name is Maria Flores. I'm from Florida International University. I actually graduated about a year ago. Now I am working at an architecture firm, but while doing some research on climate change and a project that I would like to present to you all today, which is called The Colony. This project I did as a one-year postgraduate master's degree, along with Professor Neil Leach and Alice Reed from FIU as well. So I would like to talk a little bit about the project in terms of what I found interesting and why I started pursuing this. So being from Miami, I'm actually from Caracas, Venezuela, but being from Miami and living here for about 12 years, I realized that Miami as a city, it's very beautiful, extremely cultural. It has, it's a melting point for all cultures around the world. But I realized that in the future, in the year perhaps 2100, we could be having some problems with the water entering. Why do I say that? Because we have some parts of the city which are called Brickell and Brickell Bay or Miami Beach, that right now when it rains or when we have hurricanes, the water actually comes into the city, which disables people from using transportation methods, which here in Miami, it's usually all by cars. So here's another picture this is the Brickell City Center. So I was imagining what would happen to the city, right, if in 100 years we won't have the streets anymore. What would happen if the water actually comes in and takes away that street elevation that we're so used to? So my research started by looking at the existing sea level that we have on the left and seeing what the projected sea level rise is. Of course, this is a very diagrammatic, and I was thinking that perhaps, you know, looking at a more scientific research, the water would go up every 2 meters for every 10 years or every 20 years. So I said, okay, let's look at catastrophe. Let's look at hurricanes coming in every year. Let's look at tornadoes or whatever, every natural disaster that could occur with rain. What would actually happen in the worst situation possible? I mean, as we can see, the pandemic was something that we were not expecting and it happened. So what if we actually do and explore and research a very catastrophic natural disaster that could happen to Miami or any city within sea level that could occur. So my projected sea level rise would be 7 feet to 10 feet in the next 50 years. So what would that mean for the next 100 years, right? So then my understanding was that here in Miami, we don't really have existing green space. We don't really have parks within the actual city. It's mostly buildings. So I'm proposing to have more green space, but how can we do that? If the street level is going to be completely taken away from the water, what would actually happen to the green space that we have now and that we need as a society? So then I started looking at maps, right? So this is the Brickell area that I was talking about before and where I mostly concentrated. What would happen if we start raising the street level? Instead of the street level being at 0, here in Miami, we don't have any mountains, we don't have any topographic elevation. What would happen if we actually raise the street level to be at 50 feet, at 70 feet, 100 feet, right? And then we start connecting the buildings to one another at an aerial level. And then actually creating islands that go outside of the bay and connecting them to the rest of the city. So this was an exploration that I did of superimposing materials or any type of concrete structure that would be superimposed on top of the sea level, on top of the water, and then creating an extra set of buildings on top of the water. But then I realized that when I looked at it, it wasn't really, we were creating more concrete structures. And that's not the point, right? The point is not to bring more concrete and more infrastructure to a city that is already getting depleted of its materials. And then here's a model that I did to kind of understand this exploration and understand it a little bit better. What would happen to the sea level rise coming in? How would people actually walk? And here you can see the platforms that I was trying to incorporate into these buildings and how to connect everything together. So now, in the next year of my research, I started understanding and focusing on only one area, which had about 4 buildings in general. So I started doing drawings because that's how I communicate visually and how I communicate to other people with drawings and understandings. So I started drawing specific viewpoints of the city and how they would actually look if the water came in, right? And then that's where my understanding came in about what would happen if we tried to recover, right, parts of the buildings and materials that are going to get taken away by the sea level. Let's say that the sea level rise comes in at 50 feet. Well, obviously below those buildings, we're not going to have streets. We would have corrosion to the concrete, corrosion to the metals, to the steel that basically keeps the structure intact. So we would have to reinforce that. But what would happen to the materials that are now underwater? That's when I started thinking about a different society. And my project is one architecture and then the secondary aspect of a new society that would be called the colony. And a society in which we could have different types of people that do various roles. For example, we could have scavengers that would take materials from the water and actually start creating and carving the buildings to better connect them to one another. So here we have the structure of the building. And here what would happen is that we would take everything away, every material below the 50 feet to the street level, take that away and now use it to create posts or concrete posts or beams that could make like a railing system or a street elevation at a different height, so that then we can start carving those buildings out, taking those materials from the buildings and using them for something else. And what would happen is that if Miami stays like that in 100 years, the rich are the only ones that are going to be able to keep the apartments. I mean, it's going to be better for the economy, for them, right, to be able to rent out these amazing suites that are now on islands. So we want to take the advantage from the rich and give it to the community, right? What would happen if we carve out apartments and actually make green space out of those carvings? So then with those materials, we can start creating walkways or screens for people to actually walk around at different elevations throughout the buildings, and bring the street level now to 50 feet, to 70 feet, to 100 feet, and create a circulation. So now I'm going to go to here. I have a file that I created for okay. Can you all see the new screen? Okay, perfect. Okay, so this is where I started looking at actually that, let's say that small area of Brickell that I started to now explore in more depth. How could these stairs or circulatory systems actually be held? We would need scaffolds. We would need structure that connects the buildings to one another. These columns that are now bare can now be used as a forest to create trees, to plant trees and actually create green space inside of the buildings, inside of apartments. And the interesting and fun thing about these models is the fact that I did them with materials that I would search, that I would find on the streets. As you can see, here's a receipt. And this is like plexiglass sheets, columns or little sticks that I found to be called columns. So this is how a community would be created. You don't really need all these high-end materials to create something. So then here is a model of superimposed Brickell in the back, where you can see the water in the back, and this new colony starting to create screens where people can walk around and use all the levels of the building for something completely different. It could be apartments, it could be green areas, it could be cafes, it could be restaurants, it could be schools, wherever you can fit inside of the building. And now we don't have to use the street level anymore. So to kind of wrap this presentation up, the project also consisted of stories, right? And that's where I used, as I said before, my technical abilities in drawing to superimpose this with renderings that I created. And then showing a little bit more in depth about what I would visualize in these areas of Brickell and what could actually happen. So here you can see this could be an amphitheater or a park or something where people actually can walk around. So that's one. Then I would create these stories about different personalities within the colony and what they can call a home. And I would have these comic book settings where I would show what it looks like to live within the colony, right? So this is a person that is waking up and they live in these pods, right, within the colony, and they go out and search for food. This is a place where people go to actually rent a womb, and this is in the middle of the street. So they go in here to actually get a baby, right? So it's now a different society. And what could happen if we start to create a new community from a disaster, how to get away from that, how to build on as a community, and how to find a better way of communicating with others through the architecture. So here's the womb center. Some people, right, creating these genetically modified babies or something like that. And then these are the parks. Where do people shower? If we don't have apartments anymore, do people now shower in the streets, right? And is it okay to be naked in the street, right? So it was more of a public space and understanding about what as a society can we entail psychologically and mentally, and how can we live with this new understanding. And then this is another method of transportation. We're not going to have cars anymore, so we would have to require bicycles or any other type of transportation system. This is another one with the public space. And then finally, this is one that has water, and what would happen to now the under the water, because now people wouldn't really go to the street level anymore. So what could happen now with the water? Is that where we're going to get our food? Is that where scientists are going to be located to actually get us fish and food? Where are we going to get the food? These are the scavengers that are now going to be looking for different materials to continue building up the colony. This is another sketch of how the colony was created and what happened to the migration. And now finally, these are the scientific labs where we have genetically modified foods, etc., which I call the crop lab. And yeah, that's pretty much it. Thank you all so much for this opportunity. Thank you.
Thank you very much, Maria, for bringing us around all these different speculative environments. So now the last presenters for today are Sidoine, TAKAM, and Jodel Bismarc. I hope I pronounce it correctly. Well, maybe we have Mariam Morsi with us from the American University of Cairo that can help bridge the gap of communication, because our next presenters don't speak English very much. So maybe Mariam, you can help introduce them in the conversation.
Sure. Thank you, Antonio. Donc finalement, j'invite Jodel, MEKEMTA et Sidoine TAKAM de l'École africaine des métiers de l'architecture et de l'urbanisme à prendre parole.
You are muted, guys.
Yes. Hello.
Hi.
Hello.
Bonjour.
On vous entend, oui.
Ok. Merci déjà de nous donner cette opportunité d'être parmi vous aujourd'hui. C'est un très grand honneur. It's a big pleasure to be here, to be part of this great panel, this very awesome person. So we are going to share our screen. Okay, just a minute. A minute, please. Right. Please.
Okay.
Here is our presentation. Winner of several international competition related to skyscrapers, sea level project.
I'm afraid we cannot see the image.
Yes, the screen. Hello.
Oui, je vous entends.
Is it okay?
No, we can hear the voice, but not see the image. There is just a blue panel.
Sea level project, healthcare project, and many others, all published in international magazines. I've also collaborated with different architects, many projects. I'm convinced that just
No, we cannot see it.
Alors, on entend la voix, mais on ne voit pas l'écran.
Ah, vous n'arrivez pas à voir l'écran.
On voit, enfin, c'est tout noir.
Okay. Okay, I sent the files to Sir Antonio now. I don't know if you can download it. I share the videos now in your mail.
Okay.
Because here we have some technical problems with our connections.
Okay, so well, maybe let's do like this. We can maybe kind of start a little bit the conversation also with the other presenters, and wait a second that well, it's relatively fast. So if we wait 1 minute in between, then I think I could play the video from my computer. A few seconds to go. Okay. Apologies for the technical difficulties, but there was a mismatch with the emails in trying to sharing the file earlier.
Yes.
Okay, give me 1 second.
Hello, my name is MEKEMTA Jodel Bismarc from Cameroon. I'm an architecture student currently working my master thesis project at EAMAU. I'm an award winner of several international competitions related to skyscrapers, sea level project, healthcare project, and many others, all published in international magazines. I've also collaborated with different architects in many projects. I'm convinced that just the Writer Hill Society, architecture teaches, balance, shares, and offers us a second life to existential condition.
My name is Takamike Sidoine Constant. I am a Cameroonian student in my last year of study at EAMAU in Togo. And currently, I am working on my master thesis in architecture. I will also say that my passion of architecture has pushed me to collaborate with many architects. And to date, I am a laureate of several architecture competitions on various thematics like healthcare, nuclear, resilience, regenerative habitat, and many others. So in summary, I am a great fan of architecture.
Now we will briefly present our project entitled DigitalFUTURES Floating City, which responds to the theme of climate change and sea level rise, section organized by DigitalFUTURES World. Talking about this theme requires a look at the coastal cities that are the main victims of this phenomenon. So our sensitivity has turned to Nigeria, the first economic power in Africa, which today is seeing its capital, Lagos, suffer doubly from this anomaly. However, it should also be remembered that the problem of sea level rise is caused by the fact that, on the one hand, the oceans are expanding, commonly called thermal expansion. On the other hand, the polar ice caps are melting, generating more water to the ocean. Finally, rising temperatures change the hydrological cycle, which affects the water supply of continental reserves. Indeed, the city of Lagos, located in Nigeria, is the most populated city in Africa, with about 20 million inhabitants. As a result, the city is subject to many problems such as overpopulation, which causes lack of housing and increased urban promiscuity. Above all, Lagos is facing floods caused by the phenomenon of rising sea levels. In addition, the presence of huge Lagos City continuation project on an artificial island called the East Atlantic City Project has a direct impact on the coastline of the surrounding communities, as its dikes constantly push the ocean fury elsewhere and accentuate the erosion of the nearby coastline. Thus, we conducted an analytical study on the environmental impact of the Eco-Atlantic project on the surrounding coast. Indeed, for the construction of Eco-Atlantic, millions of tons of sand were extracted from the waters to extend the area of Lagos. This has created huge hollows in the seabed near the coast due to this sand extraction. This hypothesis is supported by the study carried out by the local government and reveals that the seabed is pierced by holes reaching 7 or 8 meters deep, located at 25 meters from the coast. The sea currents rush in, gain strength, and attack the coastline and start the rapid process of coastal erosion. Moreover, the dike of the Eco-Atlantic project returned the sand coming from the hinterland, preventing the littoral drift from dragging the sand that fills the surrounding coast, accelerating the erosion of the coast and favoring the recession of the coastal line. Faced with these problems, we have tried to provide solutions following a land-sea approach. The approach consists not only in a global approach of protection and prevention of rising waters, but also in showing the new perspectives offered by habitat on water through the creation of a small floating city combining geomimicry with the traditional architecture of the Yoruba people. For our floating mini city, we were inspired by the Nautilus shell, which is a marine species. Its shape is a spiral respecting the golden proportions that allow to obtain the most stable forms of nature. This spiral has been judiciously parceled out to facilitate the circulation of water and to house housing and basic services such as education, health, a floating forest, workshops, a market, community space, services, the pontoon, cultural space, and aquaponics.
The land approach consists in the development of the coast while fighting against coastal erosion. Firstly, under the effect of the waves, the dune sun, and for this reason, we have installed geotech steel tube near the shoring which allow the shoring to be enlarged by a natural gain of sun and favor the proliferation of the coral reef. Then, to reduce the erosion due to the anarchic displacement of the coast, we have created a dune cordon which rims the displacement. Finally, we have installed geotech steel to protect the surface of the soil from stresses due to water movement, wind, or rainfall. Thus, this tile represents the synthesis of our land-sea approach. Here we have a better appreciation of the overall plan of the project, where housing component has been the most developed. The housing is inspired by a junctions combination between the mushroom and the traditional construction of the Yoruba people, which creates a bionic, vernacular, and community habitat. The exploit model of the shelter shows us the local materials used, which are wood, bamboo, and textile. Just as the dune cordon protects the shoreline as observed in this first image, the establishment of the mangrove also contributes to fight against coastal erosion through its long roots. A closer view of the dwelling allows us to appreciate their simple and minimalist form, respecting the local way of living. Also, the design is made to allow a good transverse and natural ventilation, a good zenithal lighting, and especially the recycling of rainwater. In the logic of sustainable development, we have integrated the concept of zero waste at the biological level by creating a system of recycling of the material to obtain natural compost reusable. The entire floating floor is made of wood and rests on recycled barrels. We observe on this image the access of the housing by the pier. Still in the logic of sustainability, we propose an aquaponics system that supports the needs for food. The system here is a combination of fish farming and hydroponics. This can be seen very clearly in this picture. The African culture is based on the community spirit. So we have proposed this central space of exchange where a variety of cultural activities can be organized. We also have spaces for recreation. In conclusion, the problem of sea level rise and climate change is a phenomenon that architecture today is giving itself the means to solve, both by restoring unstable ecosystem but also by offering new perspectives of construction on the water. Thank you for your attention.
Thank you both. Merci beaucoup. And thanks everyone for the presentations. I think now we can transition to have a conversation about them. There are quite a few questions in the chat and a few questions that I have noted down, but also feel free to perhaps pose questions to the other presenters while you are answering questions posed to you. I think maybe I would like to start just recalling one point that Othmane mentioned in his presentation that I think could open up to a question for everyone. You closed your presentation with a photo from, you said, the windest, coldest, and driest point of Antarctica that, as you said, could be interpreted as a barometer of the climatic situation and of the changing of this climatic situation in that region. No? So I think this concept of visualizing the situation of a very large and complex environment by like visually perceiving the condition and is what makes this place act as a barometer, no? And since we have seen a lot of places around the world, I was wondering whether also the others would like to reflect about this concept and share which situations in the context that you have approached could be considered as a barometer of this complex environmental condition related to the water presence, both of the sea, of the rain, of the air, and so on. So this is addressed to anyone in the panel, which barometer condition, which place do you consider could be a barometer condition in the context that you have studied? Maybe Alberto and Nicoletta, do you want to start?
Well, if you want. Well, as barometer, well, in our case, we are working with the Atacama Desert. So this it's super complicated to understand that. And it's curious that a phenomenon that is happening in summertime, which is the it's weird because you have rain in summertime and in Atacama Desert. But the problem is this one, when as barometer of indicator of global warming, is that now these rains are coming in a quite random way and creating some floating problems in the higher mountains and as well in isolated communities. But that means, on the other hand, that we have a drier coast because we have this imbalance. And that is the barometer that we have in our area. Now the lack of humidity in lower levels versus the higher rainy variations in these areas in the altiplanic sites. So is this a kind of imbalance that we can appreciate now? Is the barometer that we have in that place? As well, the lack of green that if we compare these sites centuries ago when the conquerors arrived, these places were super green, and now these places are absolutely dry. So that's another phenomenon we can use as barometer as well.
Yeah, definitely. I don't know if we can ask also TAKAM and to come into the conversation. Maybe Mariam, can you help?
Yes, sure. Would you mind just repeating the question so I could reformulate it properly?
Yeah, like we were reflecting about the concept of visualizing the impact of this environmental condition through specific places or specific conditions that act as a barometer that showcase this change, and what in the context of the project that they shared could be these situations that visualize this change.
Ok, so Sidoine, Antonio, il essaye de vous poser la question, comme quoi, quelle est votre perception dans la visualisation de l'impact dans des endroits spécifiques, avec des conditions spécifiques qui actent sur le baromètre, qui reflètent donc sur un changement climatique. Donc, quels sont vos projets ou expériences ou comment voyez-vous ce changement?
Yes.
Oui, on vous entend.
Oui, pouvez-vous redire en fait la question? Pas très bien.
Est-ce que vous pouvez juste hausser la voix, s'il vous plaît?
Pouvez-vous répéter la question, s'il vous plaît?
Je voudrais vous poser comment vous visualisez l'impact dans les lieux et les conditions spécifiques qui agissent comme un baromètre reflétant ce changement.
Ok, nous vous remercions merci beaucoup pour la question posée. Voilà. Effectivement, le monde faisant face à ce changement climatique est un phénomène qui gangrène nos sociétés. Effectivement, à ce changement climatique vient s'ajouter le problème de la remontée des eaux. Et on observe ce phénomène grave dans les côtes africaines ces dernières années qui, au fil du temps, le problème s'accentue. Nous pensons que l'impact est assez grave. L'impact est assez grave sur nos écosystèmes. Voilà. Et puis, nous pensons que l'architecture doit, en quelque sorte, venir répondre à ce phénomène qui, plus ou moins, essaie de gangréner nos sociétés. Et c'est comme ça que le projet que nous avons proposé au niveau de Lagos, ce projet-là ambitionne donc de venir répondre à ce problème parce qu'en tenant compte de l'impact environnemental, les sociétés souffrent par rapport à cela. Et nous avons donc pensé que non seulement essayer de résoudre ce problème au niveau côtier, parce qu'il faut le dire, l'architecture dans nos villes ici là, en Afrique est quelque chose est moins développé et l'urbanisme est pensé uniquement au niveau de l'interland. Nous avons pensé que pour ce problème-là, il faudrait que les architectes de chez nous pensent également à se réapproprier de nouveaux espaces pour essayer de s'acquérir parce qu'il y a ce phénomène-là, comme le disent souvent les philosophes, il faut combattre le problème en s'acquérant de la cause. Voilà. Et puis, aujourd'hui, les océans sont d'une part la cause du réchauffement climatique aussi. Nous avons donc pensé effectivement aller conquérir ces océans-là pour résoudre plus ou moins le problème. Raison pour laquelle vous allez vous rendre compte que les matériaux dont nous proposons sont des matériaux assez durables et locaux sur place. Et il faut le dire, un projet de ce genre, de cette ordre, n'a pas été implanté à Lagos de façon anodine, pas du tout, parce qu'au niveau de Lagos, il y a eu des pensées qui allaient dans ce sens. Et comme on le disait tantôt à notre introduction, Lagos est la capitale la plus peuplée d'Afrique, donc ajouté à ces problèmes-là, il y a la surpopulation. Donc, non seulement la surpopulation, nous assistons à Lagos au phénomène qu'on appelle la promiscuité urbaine. C'est très grave de ce côté-là. Nous avons donc pensé que pour réduire plus ou moins l'impact de la crise climatique et de l'avancée du niveau de la mer, on va donc aller conquérir de nouveaux espaces d'habitat. Et c'est pour ça que nous avons non seulement au niveau de la côte, parce que vous allez voir compte qu'au niveau de la côte, nous avons essayé d'installer des tuyaux textiles. Voilà, là, c'est une question d'éviter le dérodement de la dune côtière. Voilà. Et plus ou moins aussi, nous avons installé des tuyaux textiles. Ça, c'est toujours pour venir répondre à cet impact sur notre côte. Et pourquoi nous avons conquéri l'eau? Nous avons aussi conquéri l'eau, comme nous disions tantôt, c'est des nouvelles perspectives de chercher d'habitude. Et dans cette nouvelle perspective-là, nous avons donc voulu amener l'urbanisme au niveau de la mer. Et de ce niveau-là, nous avons donc travaillé avec des matériaux très légers et très locaux. Et vous allez voir compte que notre projet est flottant. Et ce projet flottant repose sur des flotteurs recyclables parce que les flotteurs ici là sont des fils. Donc, ça veut dire que ce sont des éléments avec du bois qui est à 90% constitué les matériaux que nous avons utilisés. Ce sont des matériaux qui ont un très faible impact sur l'environnement. Et ce sont des matériaux qu'on a au niveau de la physique, de la science. Ce sont des matériaux, le bois est un matériau qui emmagasine. Donc, ça veut dire que ça emmagasine le CO2 dans l'oxygène. Donc, ça permet d'emprisonner en quelque sorte le dioxyde de carbone parce que, effectivement, dans ce siècle, l'architecture ambitionne réduire le taux d'oxygène, le taux de dioxyde de carbone et CO2 dans l'espace. Donc, je crois qu'à ce niveau-là, l'impact est assez grave et nous avons essayé plus ou moins de résoudre ce problème-là par ces images que je viens de vous préciter. Ok, merci.
Merci pour votre réponse. Je vais leur traduire ce que vous avez dit.
They're giving you a very challenging task, yeah. Mariam, with this. But
so basically, they envisioned the future, or they created this project to solve the problem of overpopulation and the problem of housing, as well as environmental problems, such as the climatic change, which affects directly the sea height level. And so they wanted to create a solution that would resolve this problem on a daily basis and would affect positively the population as well as the urbanization in Lagos. So they thought of including recyclable materials such as PVC that act as the foundations of their project, as well as wood, which is actually 80% of their projects. And this is the main reason why they're trying to reduce the carbon footprint and to reduce the CO2 production. And also they create aquapunctures, if I'm right, in order to, to be able to give more to the community and to help reduce the impact of the negative aspects on the environment and be sustainable at the same time.
Okay, thanks. So perhaps I would like to continue on the aspect of the visualization and the communication of these issues. I would say that Maria has addressed the idea of using multiple forms of communication and multiple forms also to think of representation, to think through these ideas. And I think the interplay between more conventional architectural mapping and plans together with physical prototypes done with gathered materials and later with comics and narrative storytelling seems to be an attempt to also portray the multiscalarity and the complexity of all the issues that are related with this project. So I don't know if you would like to share about the interplay between this media and how important is the role of communication in a project that is about environmental transformations.
That's a great question, Antonio. I agree. I honestly, it's funny because when I was actually researching this project, at the same time I was teaching design too. And in design too, they are used to do linear elements and planes and stuff like that. So when I was seeing them, my students create these types of models, I told myself, you know what, I'm gonna try and do something similar to what they're doing. Because sometimes we, in terms of creating models, we wanna achieve the best quality. And I thought that perhaps by just using any material that I could find and paste it together, glue it together to something else, I would create and maybe visualize even faster what I wanted to achieve. That's why I think in my project, using these different types of communication methods, sketching, model, comics, it helped me to understand faster. Instead of just using software, it helped me understand faster what I wanted to achieve and to visualize my ideas quicker. So I would say for me, it helps a lot to have different types of communication. At one point, one of my professors and mentors even mentioned, why don't you do a video, putting everything together? And I was going to do that. So I think that for any architect out there, creating work with different types of communication, not just software, it's very good to understand things quicker and just have a more advanced technical understanding about what you're trying to decipher with the research.
Yeah, in some way, if you want, all of these phenomena deal with flows and conditions. They deal with intensive properties and a lot of elements that are not easy to translate into visual communication. No, so we have seen actually in the presentations various different types of representation that try to grasp the dynamic nature of all these phenomena. In Nicoletta and Alberto's presentation, there were computational fluid dynamic simulations that somehow have the same visual clarity of certain hand sketches and drawings that we've seen both in the presentation of TAKAM and of you. No, so there's this idea of like trying to grasp the dynamic condition of this that somehow also transcends the different type of tools that we can use to approach that. No, somehow maybe Alberto and Nicoletta, would you like to elaborate a bit more about the use of CFD or like the simulation tools that you have used in order to address that in your project?
Yes, for sure. Well, we can answer this all together, but I will start firstly with this idea of how to improve our designs, try to understand the real phenomena that we are getting from quite extreme conditions in an accelerated way. So for that purpose, we were asked to the communities on site about several key climate aspects, that including wind speed, wind directions, humidity, etc. And then we got that inside the computer, and with that we started to simulate several different shapes, trying to understand which ones are the best or the optimal, or maybe a set of options by which it's possible to understand what we can do with that. And then we realized that, well, we have an original concept, but that concept must be seriously transformed according to the site, to every country, every mountain, every hill is completely different, because all the accelerations that we can find there are completely different, as well the slopes, as well the soil quality, the sun radiation as well. So everything is different. So using the digital design, these digital tools like the fluid dynamics, has been possible to find a set of optimal solutions that we want to, over which we want to create an optimal solution now in the real world, trying to use these digital fabrication tools in the next stage. And maybe Nicoletta can talk a little bit more about that.
And also the models themselves are actually located within the exact location of the site. So we do fit it in within the geolocation of where the towers would be, so we can get the variations. I think it's very interesting to see when you, I mean, it is an interesting relationship of feeding in the different options and seeing what is more optimal. But what I really actually enjoying on Maria's presentation as well is that kind of engagement, the speculative scenarios and the community engagement. That is something that hopefully later on, or when we are to go back and engage with the community, would be something that we could adopt in terms of how can they be more aware about how to use the equipment, or how to, I don't know, like change a panel or something. So I think all of those aspects can nicely feed back into every design, and each process can really help you think through another aspect of the design, other than saying, okay, I'm using only computation, or I'm using only this. I think we understand the importance of every single part and how this can actually benefit the design and the community as well in the future.
Mm-hmm.
Anything else, Alberto?
Maybe it's something related with materialities, that we can test different materialities using the same technology, and that is part of the thing that we want to do now. Mm-hmm.
Yeah, because then it's how the material also feeds, the materiality and the material computation can feed back into the model as well, in terms of curation and maximizing capturing the water.
Mm-hmm. Somehow the relationship with the communities that are the most exposed is something very relevant for, I think, all these projects, no? And as you are saying, like, it is gonna probably also then be a very interesting process, the one of like real prototyping and testing with the communities, no? But many of the projects that we've seen then narrate what is the relationship of the communities with these environments, and what could be also the involvement of those. And I think the first project by Danielle also had an important component of reflecting about how the informal communities at the moment do inhabit those areas, and how could they be re-involved in that aspect. And perhaps, you know, this social component and the aspect of time and communication in the relationship with this community is something very relevant. So would you like to elaborate a little bit more about the role of different communities in the project that you have presented?
Yes, I think the community has a big role in these projects, because as I was showing, some of these housing projects, they didn't have a contact, a communication with the population, with the community, and that's why I think the project fails. I think the role as we as architects fail when we do like this, because we don't think about for who are we building, what is the history of these people, what are their culture, and instead what is usually done is that we just design a project for that location, but don't really think about what is the relation with this location. And I think it's really important to communicate with the communities and to understand what they want for the house, how do they live, before we start designing.
Yeah. So there are quite a few other questions also in the chat by other members of our team, and I think it would be nice if Gustavo, if you want to join the conversation by directly jumping in and posing some of the questions. I think it could be nicer to expand the presence of the team. Hi, Gustavo.
Hello, everyone. Thank you, everyone, for your wonderful presentation. I'm sorry I'm a little informal right now, but my question is for Othmane. Actually, I had a really interesting time speculating and understanding what you were doing, but can you please discuss the objectives of this type of research, and what are the scientific, political, and economic implications of what your project is implying?
Sure. Thanks for the question. It's really interesting. And just to give you a little bit an idea about the overview of this kind of research, at the beginning, we tried to kind of understand and sort of visualize the sort of geopolitical system that governs, in a way, the most kind of extreme and experimental of all the continents in our planet. So in a way, this research kind of, in a way, aims to kind of construct the first sort of comprehensive Antarctic atlas, which is something that was not available at that time. And on one side, we had to kind of sort of chart the sort of evolution of the polar architecture while kind of unfolding other implications, for instance, the Antarctic Treaty. This is signed by 12 countries. And this is a treaty that obviously allowed the human activity and try to kind of protect and govern at the same time the entire kind of area. And the treaty, which is a political element, kind of transformed the continent into a sort of laboratory. That's why most of the time the design experiments that have been done in the past and are happening there in Antarctica are really helpful of the research that is done in space, because it's something that is not really kind of relevant. And obviously Antarctica fails, in my point of view, the idea of being a place where to live for obviously different climate reasons, but also kind of reasons related to landscape. And in a way, the treaty tries to kind of non-nationalize the entire territory. They try to kind of demilitarize it, and at the same time, they devote it uniquely to kind of research on science and research. And every government, in a way, from a political point of view, sort of claims a limit and of certain regions. And a few of these countries, for example, have mutually kind of recognized each other claims. This means that you can literally build your base and have a base in other people or other sort of government's territory. And when the treaty in a way has been signed in 1983, there was a sort of coalition of this internationalization that launches at the same time other pressures on this government, such as how we can protect the land consumption, or how can we kind of resolve the issue of the climate change. Because obviously the type of construction and type of urbanization that is happening there is protected by the treaty, but is not 100% kind of related to the sort of government agenda. That's why it is important, I would say, to kind of look also at the way in which the continent has been urbanized and is urbanized at the moment.
Thank you. I also wanted to follow up with the, I think Sidoine, I guess, their team. And just to ask, when you visualized your, let's say, your floating city in the spiral, were you thinking about the implications of kind of the long-term sustainability? Like, how would that plan scale up in North America? How would it scale up in another country that might have issues with flooding and with the land disappearing?
Donc, je vous réadresse la parole. On voulait savoir que si, lorsque vous visualisez votre série flottante en forme de spirale, comment ce plan pourrait-il être appliqué, par exemple, en Amérique du Nord, où ils ont aussi des problèmes d'inondation, ou dans un autre continent?
Ok, merci, merci pour la question. Et je pense que par rapport à la forme de notre projet, nous avons opté pour la spirale, qui est une forme biomimétique, une forme réplicable. Et lorsqu'on parle de réplicabilité, on parle également d'universalité. Et je pense qu'en Amérique du Nord, c'est vrai, il y a des problèmes d'inondation également. Et le projet est implantable parce que avec cette forme unique, cette forme de la nature, cela permettra non seulement d'avoir une meilleure modularité du projet, une meilleure façon de s'implanter en fonction des conditions naturelles et en fonction des conditions également de température. Cela permettra de mieux équilibrer l'implantation du projet. Et aussi, je vais laisser la parole à mon frère TAKAM qui va aussi dire un mot.
Ok, d'accord. Je vous remercie encore pour la question. Comme tout à l'heure, le modérateur a parlé de forme en spirale. Effectivement, la forme en spirale là, qui est tirée de la nature, comme mon frère vient de le dire tantôt, c'est une forme assez complexe, on le sait. Mais la raison pour laquelle on a voulu implanter le bâtiment, notre master plan en cette forme-là, d'abord parce que c'est une forme spirale. Comme l'a dit tantôt, la spirale, c'est une forme qui respecte les proportions d'or. Et quand on parle de proportions d'or, et si on fait allusion au Corbusier, avec le Corbusier, selon le Corbusier, ce sont les formes les plus parfaites d'abord de la nature. Ça, c'est de la nature. Ça, c'est d'un. Maintenant, de deux, comment est-ce que ce projet peut être répliqué en Amérique du Nord? Voilà. Et on sait qu'en Amérique du Nord, contrairement à notre climat, ici, nous sommes dans un climat tropical, et là-bas, ils sont dans un climat assez très polaire. Et nous pensons que, là, je vais encore revenir sur le matériau, parce que effectivement, d'abord pour le master plan, ça sera implacable là-bas très facilement parce que nous pensons de ce côté-là, la technologie est assez avancée par rapport ici. Donc pour la faisabilité du projet, on ne s'inquiète pas pour cela parce que si ici là à Lagos on peut l'implanter, ça sera une chose très facile de ce côté-là. Ça c'est deux maintenant de deux. Et nous avons utilisé le matériau bois. Voilà, je tiens à le marteler. Et en Amérique du Nord, la quasi-totalité des bâtiments sont en train de se faire en bois. Déjà. C'est-à-dire qu'on parle déjà de il y a des lois qui accompagnent les maîtres d'ouvrage qui déjà ambitionnent d'implanter le projet avec du bois. Et le bois, c'est un matériau qui s'adapte au froid parce que là-bas, c'est un climat très froid. Donc, nous pensons que le projet, dans tous ses apports, maintenant, avec sur le point de l'implantation concrète du projet, là, il devrait maintenant s'agir de l'intervention de la science pour la maîtrise du matériau. Parce que là, le matériau ne sera pas choisi de façon anodine. Il faudrait maintenant que les scientifiques de ce côté essaient d'étudier maintenant le matériau bois. Parce que le bois qui s'adapte au climat tropical ici ne sera pas le même bois en termes de conductivité, de transmission des chalets et tout ça. Il faudrait donc. Le seul souci peut uniquement s'agir au niveau du bois. Sinon, la réplicabilité est très faisable et nous le pensons vraiment. Merci pour la question.
Merci à vous. So basically, they said that the form of the project was inspired from a mythic form, which is inspired by the golden ratio, and it's also respecting the proportions of the water. So they said that if they would be applying this shape in North America, it wouldn't be the same. It would be using different materials because of the difference of temperatures, for example, of the water, and also like I said before, they use like 80% of wood in their project, and it wouldn't be possible to use this material in America because of how it would react to the temperature difference. And also that in North America, they have a lot of technological advances compared to Lagos. So they would think of a different shape as well as different materials.
It is interesting that actually one of the most famous interventions in waters in North America, the spiral jetty by Robert Smithson, has some formal resemblance and also environmental resemblance, because it's one, of course, very interesting experiment of environmental transformation. So thanks a lot for helping in the translation of this. They don't make it too easy for you with this answers, but
that's the best part. We're here to have fun this today, for sure.
Exactly. I wanted to launch maybe a last reflection all throughout that I think is one of the crucial issues regarding climate change, of course, but more specifically regarding the role of water. That is about the understanding of quantification. Like, we're dealing with the increase of temperatures that is statistical, that is based on data throughout the last century, when we started collecting data. And there's a lot of different numbers in different media, in different narrations of it. But every one of these projects, I think, deals with the quantitative side of that, and is oftentimes difficult to grasp what is the impact of one specific variation or another, to also quantify what is the role of more or less quantity. You mentioned about the quantity of water that the towers can harvest, and it's not easy to visualize it. Othmane mentioned about so many quantities that are changing in the Antarctic region, or that change seasonally, and we rarely have a very tangible sense of these quantities, no? And so for me, I think it also then falls back onto a question of communication, in the sense that understanding this quantitative aspect and being able to discuss about those in broader terms becomes a crucial point. So I wanted to maybe make a reflection on this, and maybe ask openly to anyone who wants to address, but maybe Othmane, that has used a lot of data visualization in the presentation, about how important and what are the trajectories to be able to make more explicit or make more tangible this large and complex quantitative data.
Sure, I'll try to. It's a very interesting question, and very, very complex, I would say, for several kind of reasons. I would say the importance, in a way, of having data at the beginning, especially at the beginning of a design process, that in our case is the design of a base, or for what would be like in the future a possible city in Antarctica, give us importance about trying to kind of squeeze the informations and try to kind of summarize which are the parameters, in a way, that drive the design, or that drive our kind of thoughts as designers or as architects into a sort of a specific issue. So, for example, the water and the climate rise up in our research and our kind of data of these several scenarios, because obviously it's one of the issues that the bases in this case and all the governments have to deal with. So as I said before, almost 60% almost of the world freshwater is reserved in Antarctica. This means that also behind the kind of interest on how the base kind of deal with the water and with the waste management, etc., the government that has, in a way, kind of political duty in that territory, has also political duty on managing the resources and the water on the political kind of regional area of Antarctica. And obviously the kind of I would say the territories are located that obviously signed the treaty are located in the world. So for example, I would say there's the US, there's the UK, and I don't know, there was also like an interesting article a few months ago where part of an iceberg has been moved from the North Pole to another country. I don't know if you remember about that famous article where actually there was a ship that literally just cut a piece of ice from the North Pole and then has been transported to another territory because there was a need of water in that specific area. And this obviously raised up a lot of concerns, which means who is kind of the person liable of this, of the management of the water in the planet? Because obviously there are areas that there's obviously a lack of water, and there are areas where obviously there is a necessity of water. But the problem is that who governs the management and at the same time, you know, the resource, because for sure in the future, water will be the main kind of issue in our planet. I'm not sure if I answered the question, but I try in a way maybe to give an overview about what specific kind of.
Thank you. I just wanted to jump in real quick because I'm looking at Danielle and Maria and my screens, and it was really interesting after Danielle, she gave her presentation. Othmane, when you were looking at, when you showed the typologies, I was thinking at some point, and this is where Maria comes in, we're all speculating a future. Like we don't know how the climate is going to work. We just understand what the scientists are telling us of massive displacement and definitely this economic compression. Like, what do you guys as a kind of like future leaders, now you're telling all your, you know, your professors, your clients, like, what are the things that you're looking for now? And how do you come together as a profession to move us forward? Are your buildings more robust? Are they more expensive? Do you ask more, you know, clients to understand more of some of the moves that you make or the details? Like, this is for Danielle and Maria specifically.
Sorry, can you repeat the question?
Oh yeah. The question primarily is that does your professional work now, how is it impacted with climate change? Like, how do you tell your client, I need things to be more expensive to get more materials, or for you to have more time for research?
So I think for the clients, it's not very easy to see how important it is for them to use techniques to build buildings that are more adapted to the climate. But I think we start talking to them about the benefits of the green buildings, about also the reductions of costs, or operational costs in the building, if you use the right materials, if we use ventilation, for example, in tropical climates. And I think they start to understand the importance of using these techniques also for their lives, for the building, the operation of the building. And yeah, I don't know if that answered the questions, but I think it's a bit difficult to talk with the clients, but I think it's changing right now. They are starting to see the benefits of it.
Yeah, Gustavo, this is a very good question. And I agree, it's difficult to think about a future. Like, at least in my project, I was thinking about 100 years from now. I mean, the data that we have is data that it's past data. Like, we don't even know if the data currently makes sense, right? So we're in a way speculating. And I guess at the end of the day, our projects need to deal, at least the research projects need to deal with the worst condition. right? It's like that whole thing that I was talking about before. We didn't even know that there was going to be a global pandemic all of a sudden, right? How are we not going to know that there's going to be natural disasters in 10 months, or the fires that happen in Australia, right? Like, we don't control the environment. So I think at the end of the day, we have to build for the most drastic situations. And for the clients, at least here in Miami, it's interesting because, I mean, Miami is expanding very rapidly with real estate. I mean, all the developers and investors want to have a building here in Miami, but they don't understand the implications that causes, right? Because exactly the whole point that they don't know the data. And when they see it in terms of the money that they can bring in, it's better to have a city that is more water is going to be coming in, because it's better for quote unquote the rich, right? Because it becomes like islands. So you have developers are more interested in that. But to Danielle's point, they are understanding more about LEED and about sustainable design, the whole ventilation throughout the buildings, and getting a whole certification in the different LEED aspects. I think that clients are very interested in that, but they're more interested in the sense that it makes the building look better, rather than you're actually helping the community around you, you know?
I just wanted to do a final follow-up with everyone on the panel, but mostly it seems as though that the obstacles that we have as architects and scholars has to do with our relationship with science and politics. Mm-hmm. Because if architects were seen more as engineers, or let's say doctors, right? Then, then we would have the respect to actually spec a material, or to have a certain engineering detail, or an understanding what the issues are, to request a report or an analysis of a site, right? So how do you guys, as the future of the field, what should be more of the relationships that should be made with architecture, the discipline, science, and now with governmental policy with climate? Like, how can you make a difference, and how do you think you guys should come together?
This is a big underlying question to all, let's say, this, to almost all our sessions, I would say.
Yeah, well, I mean, for Alberto and Nicoletta, I was thinking, well, why don't governments pay for this type of research from architects and work with engineers to make this something that could scale? That would be an example.
Yeah, it's a super interesting point of view, because it's part of our experience indeed. Let's say this in this way. From the South American perspective, at least, governments are working with things that are getting results in quite short time. So because it's super political, so they want to win an election, so they want votes. So let's work with the guys that can provide votes. So you have an importer there can buy some machinery for producing water from the sea, instead of these other alternative technologies. And then, okay, they pay for that. Then they got the machine, and then they won the guy won the election, and then the machine just fails, and doesn't matter. Let's buy another one. This is super complicated. That's with this example, because at the end, everything is related with trying to invest just for the shorter results, instead trying to develop something related with a real problem, with a real involvement with the community, trying to create some technology from the bottom-up idea. In that way, maybe as architects, we have the possibility to deal with between real problems, and then we trying to scale that to another actors, maybe sometimes more international involved, instead just inside the same countries. So like this example, because This is a joint venture between several actors in local communities and international as well. So, and the government is not there. It's super weird in certain way, but it's part of the game in which we are playing now. Hmm?
And
I mean,
I don't know.
sorry, Nicoletta, go ahead.
No, it was very brief a comment. I think it would be key, the collaborations within the community and within the scientist community as well. I think it would be very key on how we can evolve as, I don't know, how we can put more pressure even to the political aspect, because if the public are not aware, which, I mean, clearly some parts they are, but I think we really need to raise and work with the communities and with the scientists in order to really push things forward, and for people to actually come and request it, because currently we have contractors that, like in normal offices, that they come and say, I just want to reduce the cost of the panel, and they don't really care about the impact that has. So we want them to come and kind of develop and educate that, become part of the process.
So, somehow it seems to me that it becomes more and more apparent that this whole conversation, and also as we framed it 2 weeks ago in the previous sessions on this topic, is very much an issue that helps the discipline of architecture and design become more of a political actor, and like act in the political environment and relate to different political frameworks. We have somehow again seen, as we said at the introduction, an interplay between a very global condition and very different local situations of dealing with it, and very different local political framework, to the extreme of the Antarctica, that is, as Othmane has interestingly addressed, the only place on the planet that does not have a very defined political framework, because it's the land of the only land that is not governed by one political entity. But that's like a very big question.
No, I'll probably go in the opposite direction, but this is obviously just my point of view, but where I consider the figure of the architect obviously as a political element in the society, not just obviously as a figure that is situated on the boundaries on one specific aspect. I think that we have, in a way, the knowledge, and in the past this happened already, that the role, in a way, of the architect in the society is obviously highly political, rather than just only related to design, because obviously this is in consideration several issues within the design process, such as the community or the role, for example, of our kind of built environment in the society. So I truly consider that our role is political. The question is, for me, the figure, in a way, of the designers or the architects within the political sort of agenda. That's the figure. And most of the time, who is the person that takes the responsibility, in a way, of the actions? Is it obviously interesting to consider that in recent times there are more and more figures involved in the design process, something that was not happening 50 or 100 years ago, right? Such as I would say, several consultants, several kind of expertise that are kind of introduced in the design process. And it's obviously helped. This is not something that remove us from the center, in a way, of the design process, but this is something that support our decisions and help us to kind of make better places or make better decisions for a specific environment or a climate, like in this case.
I mean, Othmane, I would agree. Sorry, just quickly, Antonio. I would agree that our roles are, I think, more important now because what we're dealing with is a spatial issue. It's an environmental issue, and it's an aesthetic issue. It's basically everyone has their own understanding of a good quality of life, but architects seem to be in this center where we can imagine what that would be like over decades, right? But at some point, I'm understanding that the world doesn't work that way. Were we as architects ever the center of anything is the major question. And I would say no. But I think we as a profession need to fight to be back into the center and maybe more next to the heart and the head, the intellectual head of these policymakers. So, I mean, Antonio, working with Antonio in the last few months, I realized that I bring something special, but he brings a lot of passion and a lot of, I would say, spirit. And that's what I enjoy about a global community. And I think if we're trapped in our own worlds, we don't share the trauma or the problems. But now that we see that the problems are pretty much same in different parts, I think we can help each other as a community. So, I mean, my final thoughts are, thank you very much, everyone, for coming today. I really appreciate your energy and your time and sharing a little bit of your ideas. But I would encourage all of you to become closer to this world community that we're building. And also that if you ever need help, I think we're here to guide and to add energy.
Thank you so much.
Thanks, Gustavo, for this final remark. And I think this can lead us to, we've passed a few minutes, 6 p.m. here in Central Europe, and I think 12 in the US, and it's already midnight in China. So thank you very much to everyone, to all the presenters, and also to Gustavo for joining in, and to Mariam to help bridge the language gap with our guests from Togo. Thank you very much for joining us and for making it work. It was very nice. So thank you, everyone, and goodbye.
Thank you, everyone. Thank you, Mariam.
Thank you.
Thank you so much for the opportunity.
Yes. See ya.
Bye-bye.
Bye. Thank you all.
Thank you so much. Thank you. Thank you. Bye-bye.